Ever stuck with grid-based problem in coding interviews? You're not alone. Surrounded regions is a classic that tests your ability to think recursively and work efficiently with 2D arrays. Master this and you'll be ready for any matrix challenge that comes your way. If you love working with 2D arrays and solving algorithm puzzles, this one is for you. The goal here is simple. We want to transform any zeros region surrounded by x into x. But if an O is connected to the edge, we leave it untouched. Take a look at this example. Here's our input board. Notice that the O in the top right region are fully surrounded by x, while the bottom 0 stays as is since it's connected to the edge. How do we do this? Enters depth first search, or DFS for short. This is how we'll identify which rows are safe and which one needs to go. Let's break it down into 3 key steps. The problem is straightforward. We need to identify all zeros connected to the board's edge. These are safe and should remain 0. Convert any zeros surrounded by x into x. Let's write some code to bring this plan to life. We start by defining the solve method, which takes a 2D character array board as input. The board represents our grid of x and 0. Next, we store the number of rows in the variable row. If the board is empty, we simply return because there is nothing to process. Then we calculate the number of columns using the length of the first row. To identify zeros, we use a helper function called DFS. This function will explore all connected zeros starting from the given cell. First, we check if the current cell is out of bound or if it's not, and 0. If either condition is true, we return immediately. If the cell contains and 0, we mark it as safe by changing its value to hash. Then we recursively call DFS on all 4 neighbor cells up, down, left, and right. Okay, now let's move on to marking all edge connected zeros as safe. We start by iterating over the rows and calling DFS on the first and last column. Similarly, we iterate over the columns and call DFS on the first and last row. At this point, all edge connected zeros has been marked as safe within hash. Now we look to the entire board to update the remaining cells. If the cell contains an 0, it's fully surrounded, so we change it to x. Otherwise, if it contains hash, we restore it back to 0. Since it's safe, finally, let's test this with the input example. Here's our main method. This will output the transform board showing that all surrounded zeros has been replaced with x, while the edge connected zeros remains intact. And that's how you solve the surrounded region problem step by step in C#. Also, this solution runs in OMN time, making it efficient for larger boards. Let's recap. We identified and marked safe zeros connected to the edge. We flipped the surrounded zeros to x. And finally, we restored the safe region to their original state. And that's it. Problem solved. Thanks for watching. If you've enjoyed this breakdown, give it a thumbs up and subscribe for more algorithm walkthroughs. Got questions? Drop them in the comment below. I'd love to help you out. Until next time, keep coding and keep growing.